So to find the actual mathematical areas of these shapes isn't that daunting. It requires you to be able to identify what shape you're working with, and then identify what parts of the shape you've been given, and then using the correct formula that goes with it, and then hoping that you can use your calculator correctly. So we'll start with this shape. It's definitely quadrilateral, right? The black shape, by the way, not the red one. We're finding the area of this shape. It's definitely a quadrilateral. It's got 4 sides. It appears to be a parallelogram. We can't identify it as a rhombus for sure. So we have a base and we have a height. And we know that for a parallelogram, it's going to be the base times the height. A simple enough problem, but at the same time it isn't. Because we could multiply these two numbers, right? And just get an answer. But I need you to start thinking of math more than just an answer. It needs to be reality. So I could multiply those two, but look at it, it's inches and feet. And that doesn't quite work out. We can't say it's an inch foot squared. Either they're both inches or they're both feet. Now, you might want to just pause and listen carefully here. I'm not going to really have you do this in our assignments. I'm going to give you things that have the same units for both the base and the height and the length and the width, etc. However, I do want to show you at least one example of what we do when that happens, because we need to make sure they are the same units so we can get that squared unit. So I want to change the 7 feet to inches. There are 12 inches in a foot, so that makes us 84 inches. You see, they have the same units, inch and inch, which means if I multiply this, I get inch squared. And that's legit. We can do that. Now, again, this is a very special problem. You're not going to get these problems from me, but real life has these kinds of problems. Other tests have these kinds of problems. If you're taking my science class, we do these kinds of problems where the units are not the same. Just be aware. You need things to be the same units so we can get one answer that we can agree on. Here's our trapezoid. Notice that we're given a B1 and a B2. So again, with each of these problems, I'm identifying the shape, and then I'm identifying the parts. And then now that I've identified the parts and the shape, I identified the correct formula. Here's our formula. Let's plug in the numbers. And this is what it looks like. It's important that you put these in the correct positions. Otherwise, you're not going to get the correct answer. And if you're doing these by hand, you need to make sure you follow order of operations first. So order of operations would tell me to do this first, and then multiply it by the 5, and then divide it by the 2. So here I am using Desmos, and you can see that I typed it in exactly the way you see it here with the parentheses and the fraction bar, and I get an answer of 22.5. Now, of course, our answer isn't just 22.5. It's going to be 22.5 miles squared, because this is area, and area is a two-dimensional quantity. Okay, triangle. I'm going to do this problem 2 different ways. You do not have to do triangles 2 different ways. You will do a triangle only one way, and that's going to be good enough as long as you're correct about it. However, you have 2 options, right? You have the easy way that we've known since elementary school, and then you have Aaron's theorem, which requires you to use all 3 sides, which is a lot more work. How do you know which one to use? It depends on what you've been given. In this problem, I gave you everything, so everything could be used. The easiest way to do this problem is to consider that this is the base and this is the height. So we're going to use this formula, and if I replace the appropriate components of this triangle where it belongs in the formula, I have this set up. And if I use a calculator, I get 56 meters squared as the answer, which is very nice. We use a base, we use a height. I want to show you an example, and this is where you might want to pause and rewatch and pause and rewatch. It's the same thing every time if I'm given 3 sides. So here's 3 sides that I've been given, A, B, and C. And we're going to use Aaron's theorem. Now, I'm only going to do one example in this video. You may see me do other examples in assignment videos. However, the process and the procedure is the same. The only thing that happens is that the numbers change. That is the beauty of using a formula, that the process and the formula remain the same. The only thing that changes are the actual numbers that are input and the actual output you get. So we mentioned step 1 was to identify A, B, and C. Step 2 is to find the semi-perimeter. This is our semi-perimeter setup in this case. If we go ahead and use a calculator or we use Desmos, we arrive at this conclusion that we get 19. Make sure you can do this as well on your calculator or your Desmos or whatever you're using, because a lot of times students will not use a calculator correctly and it'll give you some weirdness. If you're going to type in a calculator, you might want to put parentheses 14 plus 8 plus 16 close parenthesis and then divided by 2. Otherwise, if you don't do that, it will only divide the 16 by 2 instead of doing everything else by order of operations. So we get that this is equal to 19. And that's great. So we have S is equal to 19. Don't forget that A is 14, B is 8, and C is 16. And just as a good habit, nothing's going to go bad if you don't do this, but as a good habit, let's make the longest side of any triangle always be C, because that's actually called the hypotenuse. We'll focus on that more another day. So let's find the area. Here's a formula. Let's go ahead and plug in the S because we have that. S will not always be 19. It is for this problem. S is the semi-perimeter that we found by adding the 3 sides up and dividing it by 2. That's where that came from. So A is 14, B is 8, and C is going to be 16. So as a quick recap, remember, we're only doing this long process if all we have are the 3 sides and we don't have the height. I know this problem was given the height. We already showed you how to do that. We're pretending that we don't have the height. So we're using the 3 sides to show you the process. The first step is, of course, identify A, B, and C. Then calculate the semi-perimeter, which we found here. Then plug in the appropriate numbers. And now we can simplify. Or if you just want to put in your calculator, that's perfectly fine as well. Just make sure to put it in like this and have all these parentheses here as well. But we could simplify this as well if you want. 19 minus 4 is 5. 19 minus 8 is 1. 19 minus 16 is 3. So if I put this in a calculator. So if we put this in a calculator, we have the square root of 19 times 5 times 11 times 3. And sorry, typo. Somehow, for some reason, I forgot that 1, right? 11, not 1. So make sure you fix that. 19 minus 8 is 11. Typing this in, I get this. Now, what this tells me is that, and I didn't make this problem myself, I took this picture from another textbook, but whoever made this problem ended up rounding some things, okay? So these numbers are not exactly correct, completely correct, but notice something. If I round this up, 55.99, it's 56, okay? And that's the same answer that we got when we did 1/2 base times height, right? We had that one that came out to be 56 meters squared. And this is going to be 56 meters squared as well. So showing you that it doesn't matter which way you do this, the fast way or the quote-unquote long way, we're going to get the same answer. Personally, I want you to do it the fast way if it can work, okay? But remember, it depends on the situation. For this problem, can we do 1/2 base times height, or can we do Aaron's theorem? Well, I have the height and I have the base, so I would do the simple one. How about this one? Do we do the simple way or Aaron's theorem? Well, we have the base. It looks like this is the base, right? But this is not, 3 is not the height. See, this is the height. That's a different distance than this. So they gave me 2 sides. Looks like they gave me maybe a side A and a side B, for example. But then it gave me the 3rd side. So they did not give me the 3rd side, and they did not give me the height. I can't do either of these. Well, for this triangle, they gave me the base is 5. But actually, they gave me this side and they gave me this side. They gave me all 3 sides, A, B, and C. they did not give me the height. So based on what I see on the screen, I'm going to have to go with Aaron's theorem because I don't know if I have a height or not. This is interesting. So it looks like they gave me two sides. However, do you notice that this is a right angle? So if this is the base, this is the height. I know it happens to be a side, but it also happens to be a height. So good news for us for this problem, they only gave me two sides, but in this case, they gave me a side that was a height and a side that was a base. So I could get away with this using this formula right here for this problem. And then for this problem, they gave me one side and they gave me the height. So this is the height. But if I was going to do the simple problem formula, I would need this base, which I do not have. They gave me one of the other sides, which is not good. So remember, if I'm going to be using, so this one is neither of them. Now remember, if I'm going to do this one, the simpler one, right, I need to have the base and I need to have the height. And usually the height is going to be labeled with this little perpendicular sign. Okay. If it's Aaron's theorem, I need to have all three sides. Now, if it fits in neither of these two options, then we can't find the area of the triangle. So it's very important, now that I've shown you how to calculate the area, you have to first decide which of the two formulas would be the most appropriate to use, or if you can even use any of the formulas. For your summary, for the triangle, explain in words why it was done two different ways, and when do you use a certain formula over another one.